Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Fakira Nabila binti Hasli and my number matric is DE210001. So for my question is question number 1, that we need to prove that dy over dx equal to 6x power of 2 y plus x power of 3 over negative 2x power of 3 with an initial condition of y1 equal to 0 that has a particular solution which is 8 8x power of 3 y plus a plus x power of 4 equal to 1. Given that the differential equation is either linear or homogeneous. Okay, for the linear equation, this is the mapper coding that we use for the simulation. First, we need to define the variable with the given differential equation, and then express the equation in the form of dy over dx plus pxy equal to qx, and then identify the px and qx. So after that, we'll find the integrating factor I and then multiply the differential equation by the integrating factor, and also integrate again with both sides of the equation, and the display will display the result, and then we gonna get the answer, which is 8x power of 3 y plus x power of 4 equal to 1. Next, for the homogeneous equation, so this is a homogeneous coding equation, which is we need to define the variable first and then give with the given differential equation, then express the equation in the form dy over dx equal to fxy, and then substitute y equal to vx and dy over dx equal to v plus x divided by dv over dx into the differential equation, and then solve the homogeneous equation using the method of separation of variables, and we substitute back the v equal to y over x back into the solution, and the display will display the result of the homogeneous equation. So this is the result of the coding, homogeneous coding. So that's all for me. Next, I will pass to the next presenter that will present the question number 2. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Faiz bin Zainal Abidin. My metric number is DE210014. So today I will be presenting about the question 2A, second order non-homogeneous equation. So for this video, we will talk about question 2A, how to find the homogeneous ODE. So I use Maple. First thing first, just code restart, and then define the function and the homogeneous of ODE, which is y equals to x yx. So homogeneous ODE is diff y and then bracket and then x and then minus y and then x equals to 0. So it will become like this, and then just simply solve the homogeneous ODE using this code. Homogeneous solution equals to dissolve homogeneous ODE and then semicolon, and then you will get this one, and then display the homogeneous solution, and then you will get this one. So that is all for 2A. So for 2B, we will use the undetermined coefficient method. So as usual, just define the function and the ODE, this one, and then ODE diff, the same code, ODE diff yx xx minus yx equals to x times exponent x. So you will get this one, and then assume a particular solution of the form a times x plus b times exponents x. So you will get you need to enter this code to get this kind of particular solution, and then you will get like this, and then add the homogeneous solution to the particular solution. So homogeneous is not shown here, so homogeneous and then the particular solution. So yc plus yp, you will get the y general equals to d soft ODE yx, and then you will get this one. So it is only from until here, but you can also display the y solution to the simplify plus ps particular, but we don't have any, so the answer is here. So that's all for 2b. So for 2c, we need to find the variation of parameter method. We need to find the second order using the variation of parameter method. So first thing first, you need to find the homogeneous solution using this code. Homogeneous underscore solution equals to d soft div y x minus y x equals to x. So it's the same as previous one, and the top one is also the same as previous one. And then you need to compute the Wronskian. Wronskian is equals to w equals to Wronskian, and then y1, y2, and then x, and then you will get like this. And then you need to define the right hand side of the equation, which is right hand side is x times exponent x. So this one. And then use the variation of parameter formula, which is u1 is equals to negative int y2 times right hand side over w times x, and then semicolon, and then u2 is equals to int y1 times RHS right hand side over WX, and then you will get it like this. And then to compute the particular solution is just simply u1 times with y1 and then plus u2 times with y2, and then you will get it like this. And then display the particular solution and you will get it like this. So for Wronskian, they only show it up to this point because that's the capability of Maple only show it in this type of form. But I do the manual calculation, yeah, I get the same as the second one, which is the undetermined coefficient. So that's all for 2C.
Okay, hi, Assalamualaikum. My name is Nur Amira. I'm going to continue for the question 3A, which is it has to solve the first order differential equation question. So I'm going to explain the simulation, which is I'm going to use MATLAB simulation. Okay, so for this, I'm going to write clear and CLC, which is this coding is for to clear the workspace and the window command for the new simulation. So, okay. So it's clear right here. So next I'm going to write sims x and y, which is this is for to create a fresh symbolic variable for interactive symbolic workflow. So I'm going to create a new symbolic variable x and y. And then it will display like this at the workspace, which is we already create the variable. And then next I'm going to display the metric A, which is this metric for question 1. And then it will display like this. So metric A, 3, 5, -1 and -3. Okay, so for this coding, next for this coding, z equal to a gene A, which is we have this coding is to find the value for lambda 1 and lambda 2. For just like this step, we have to find the value of lambda 1 and lambda 2. So for this coding, we just write the coding like this, and then it will display like the z, metric from z 2 and -2, which is 2 above is the lambda 1, value of lambda 1, and the negative 2 is value for lambda 2. Okay, next we move on to metric form VA. So this metric form is just like this one. We have to minus the metric A with the value of lambda 1, which is 2. So for this step, we have to minus the lambda, the value of lambda at 3 and negative 3 only. So I write the coding to minus the value of lambda 1 at here, which is 3, and negative 3 here. Because I write like this one, A 1 and 1, which is the direction, the location of the value of 3. And then for this A 2 and 2, the direction for negative 3. So it will display like this, just like my answer here. But then this is not in the x and y form. So I write the coding bxy so that it will create the x and y form. So and then I write v1 equal to va multiply b, which is I'm going to add x and y in this metric form. So it will display like this, x plus 5y negative x minus 5y, just like my answer here. Okay, so and then this coding v1 1, I'm going to select from this either two metric to move on to the next step, which is let x or y equal to s. So for this, I'm going to select the first one, so I write 1 here. So and then it will display like this. So we select the first one, it will display like this, and then we continue the step, which is v1 equal to solve v1 like this, and like this coding. So it will do the equation for let x and y. So I got the answer here is x equal to negative 5. So so it display the answer here, negative 5y. So it's the same as my answer, but this is in the S form, where this one is in x and y form. Okay, for the last step is v1 equal to v1x. It will display the metric form of v1, just like I got here. But my answer is in the S form, and here is in x and y form. So it's the same as my answer. Okay, next we are going to find the VB metric form. So as the same as VA metric form, I'm going to write the VB metric form, which is already 2 minus the lambda 2 value, which is negative 2, at the position of 3 and negative 3. So I write here at 3 minus negative 2, and here negative 3 minus negative 2. Just like that, and it will display like this, 5 and negative 1, just like my answer here. Okay, next I'm going to display it in the x and y form. So I will multiply it with metric b, and then it will display like this, display x and y form. So 5x plus 5y, negative x minus negative y. It's just the same as my answer. Okay, next we move on to next step, to select either one of these. So for this metric, I'm going to select the second one. So I write 2 here. So it will select the second one here, just like this. Okay, and then for this coding, it will do the equation, it will calculate for let x and y to s value. So it will display like this, x equal to negative y. Just like I got here in my answer. And then for the last step, we got metric value for v2, negative y and x, just like my answer here. So that is the end of my explanation. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nadira binti Muhammad Nazib. My matrix number CE20070. So for my part, I will present and make the simulation for question 3B. For question 3B have 4 parts. For part 1, write the general simulation. YC for the homogeneous system. So to make the simulation by using MATLAB, that firstly, we need use command clear and CLC to clear the workspace and common window. Next, declare symbolic variable x, a, and b. Next, define the eigenvectors v1 and v2. v1 is 1 and negative 1. v2 is 1 and 1 over 4. And define the eigenvalues lambda 1 and lambda 2. Lambda 1 is 1 and lambda 2 is 6. So the final answer is exponent xa plus exponent 6xb and negative exponent xa plus exponent 6x over 4b. The second part for the question 3b, determine the particular integral yp for the non-homogeneous system using the undetermined coefficient method. So for the simulation, first define the coefficient such as C, D, E, F, I, J, X, and G. And next is non-homogeneous term. The term is given from the question. So G is negative 5x power of 2 plus 6x plus 25 and negative x power of 2 plus 2x plus 4. Next, particular integral yp is defined as a function of x with undetermined coefficient. So yp is semicolon cd x power of 2 plus semicolon ef x and plus ij, and calculate yp prime with respect to x. And then the non-homogeneous system of equations is set up using the undetermined coefficient method, and the system of equation is displayed. Next, the system of equation is solved for coefficient C, D, E, F, I, J. Then the solution is displayed on the result. Then the obtained value are substituted back into yp. So the particular integral yp with substitute value will display. So the final answer, we can see that C equal 1 and D equals 0, E equals 0, F equal negative 1, I equal negative 5, and J equal 0. Next is part 3 and part 4 for question 3b. First, to obtain the general solution of the non-homogeneous system. And second, compute the particular solution y1 and y2, given that the initial condition are y1 and y2 is 0. So in firstly, we need to declare the function of yc. Then after declare the function yc, next we declare the function yp. So to get the y equal yc plus yp. So to get the value of y, I declare y equal collect yc plus yp semicolon ab. Then for part 4, to get value of a and b, I use solution equals solve e, q, and s AB. In code, y solution equals subs y AB and solution A and B is declared for solve the y. We invite value of A and B.